All right. So with the ellipses, I know it looks like a ton. If you're decent with circles, it's very similar to that. So basically, you do have a center still here, but you also have two foci, which is plural for focus, like from the parabola. There's a focus here and a focus here. Um, the What this is saying is the set of all points in a plane such that the sum of the distance from two given points called the foci is a constant. There's vertices, which are the 4 points. Um, so there's two vertices, which is along the major axis. The major axis is the longer axis. The axis basically, you know those 4 points that we plotted for the circle? The axes just connect those points. So in ellipse, they're not the same. It's kind of stretched out. So the major axis is the longer axis. The minor axis is the shorter axis. And we call the endpoints of that major axis the vertices, where we call the endpoints of the minor axis the covertices. So there's two vertices and two covertices. The constant sum, we'll get to that in a little bit, the sum of the distances from the foci to any point on the ellipse. We talked about the major axis and minor axis, and the center is just like the center in a circle. Okay, so let's get on to the next one. You have your parent function one here, where nothing is shifted. The only difference is from a circle is that the x squared and y squared are being divided by something. And you have that a squared and b squared. And you see the difference between this. This is when it is horizontal, and this is when it's vertical. I know these look very similar. The only difference is this is x squared over a squared, and this is y squared over a squared. Well, basically, the a is larger than the b. So you got to know that. And so if the x squared has a larger denominator, then it's going to be horizontal and stretched out this way, where if the larger denominator is under the y, it's going to be vertical and it's going to be stretched out this way. And so your foci are going to be C0 or negative C0 for horizontal, and your vertical is going to be 0C or 0 negative C. And the C comes from C squared is equal to A squared minus B squared. So, and that's going to be the focus away from one of the away from the center, basically, because right now the center is just 0, 0. The length of the major axis is 2 times a, and it's going to be that for both of them because the a is the larger one. This one's just going to be horizontal, where this one would be vertical. And the length of the minor axis is 2b, 2 times b, twice of whatever b is. This is vertical, so I'm going to have the y squared first, and my x squared, and notice they're always equal to 1. I just need to find my a and my b, and then I'm going to have the equation. My center's at 0, 0, and a is going to be, well, this major axis is a distance of 10, so 2a is equal to 10, which is going to mean a is equal to 5. So that's going to go here, but it's a squared, so that's going to be 25 under the y. The minor axis looks like a distance of 6, so 2b is equal to 6, which means b is equal to 3. So 3 squared then is 9. This should be my equation. Now, you're always going to have one of those points. You may not have both of them. If you don't have both of them, then you will be given the focus, and that distance is 4, and that C is 4 because that's the distance from the center to the focus. So you could use this formula. 4 squared is equal to 5 squared minus b squared. And when I do that, 16 is equal to 25 minus b squared. Subtract 25. I get negative 9 is equal to negative b squared divided by negative 9 is equal to b squared, so b is equal to 3, and I can do it that way as well. Okay, so here we're going to write an equation for an ellipse with vertices at negative 4, 0 and 4, 0. That means that this is the major axis because it calls it vertices. And then the foci are at negative 2, 0 and positive 2, 0. And so as you can see here, you have this set up. I don't know where my co-vertices are, but I can start doing it, and you can either do your distance formula between these to find your center, or you can just notice from the drawing that my center is at 0, 0. And it's horizontal, so that means x squared first, and I have x squared over the a squared plus y squared over the b squared is equal to 1. Well, the a is half the distance between the vertices, so that distance is 8, half that distance is 4. It's really just the distance from the center to one of the vertices. So since a is equal to 4, that means my a squared is going to be 16. And I don't know my b, but take what I do know, and I know that the foci are here, and that means that the distance from the center to a focus is 2. So my c is 2. And I can use the formula c squared, which becomes 4, is equal to a squared minus b squared. And when I simplify this, I get b squared is equal to 12. And if I'm looking for b, I can take square root, and b is equal to square root of 12, which is about 3.5. But in the equation, if all I'm looking for is writing the equation, in the equation, I want b squared. Well, b squared was 12. So I just want to write that 12 in here, and that is my equation. If I'm drawing it, then I would want that 3.5 and 1, 2, 3.5 here, and 1, 2, 3.5 here. And that would be my ellipse if I was drawing it out. So then you can shift that parent function basically where the center's at 0, 0 with the h and the k, the same as the center, or I'm sorry, the same as the circle. The orientation is the same. If x is first, then it's horizontal. I'm sorry, the x doesn't have to be first because this is plus, so it really doesn't matter which one is first. It matters which denominator is larger. Because the x has the larger denominator, that's what would make it horizontal. Where if the y has the larger denominator, then it's going to be vertical. The center is going to be at hk, and the foci are going to be c away from the center. So when it's horizontal, you add the c to the h, or the x value of the vertex, and subtract it. If it's vertical, you add the c to the k, or subtract it, plus or minus c. And for the vertices, you're adding the a to the major axis and the b to the minor axis. It's a lot easier to do on a graph rather than doing with these formulas, but we'll do some examples real quick with the graphs and actually drawing it out. It makes it a lot easier to actually draw it out and see what it means. You just have to understand where the center is coming from, which is the h and k, and that the major axis and minor axis come from the a and b. So they're giving me the vertices and co-vertices, and I need to write the equation. I always like to just draw it out. You can find the midpoints using the midpoint formula. So here are my vertices. That's my major axis, which if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that's a distance of 10. And my minor axis is -1, -4, and -1, 0. And the center is going to be where they intersect, which is here. halfway between each. So because the center is at -1, -2, I can start my equation at x plus 1 squared, and this is plus in between, y plus 2 squared equals 1. And then I have my denominators to take. Well, the denominators are the a and b squared. The x is larger, and the a is a distance of 5. It's basically from the vertex to the center, or half the distance between the vertices. And the b is 2. So this becomes 25 under the x because that's my major axis, and this is 4 because I'm squaring the b under my minor axis, and that's my equation. If they're looking for the foci, you got to find c. So c squared is equal to a squared minus b squared, which is 21. So c squared is equal to 21, take the square root, and c is equal to square root of 21, which is between 4 and 5. So it's be 4 and 5 away from the center. 1, 2, 3, 4, it'd be somewhere about here, and somewhere about here would be the focus, or foci. Find the coordinates of the center, the foci, the lengths of the major and minor axes, and of the ellipse with the equation given. So, and then we're going to graph it. So again, just like with the circle, I need to get my x's together. I need to get my y's together. And I'm going to get the constant on the other side. And let me complete the square for each of these. So this is going to be x squared minus 6x plus, and the b divided by 2 squared becomes 3 squared, which is 9. So I'm adding 9 here. Plus 4y squared. Oh, I got to factor out that 4. Minus 4y. And then so I'm going to add b over 2 squared, which becomes 2 squared, which is 4. So I'm adding 4. So I have this 11, and what I added was the 9 for the x, and I added really a 16 for the y because it was 4, and then I had factored out this 4 here. So this part factors into x minus 3 squared, and I have 4, and this factors into y minus 2 squared is equal to, that becomes 20 and 36. And if you remember, the equation is always equal to 1. So to get this to equal 1, I'm going to divide by 36 to everything. So this becomes y minus 3 squared over 36 plus, and the 4 and 36 reduce, so that becomes y minus 2 squared over 9, and it's equal to 1. So the center is at 3, 2. So that's going to be 3, 2 right here. My major axis is my x. This is the x, so my major axis is the x, and the a is 6, the square root of 36. So it's going to be 1, 2, 3, 4, 5, 6 right here, and 6 in the other direction. 1, 2, 3, 4, 5, 6. And my minor axis is a distance of 3, the square root of 9, away from the center. 1, 2, 3. 1, 2, 3. And the foci, well, that's going to be c away from the center. And to find c, I do the a squared, which is the 36 minus 9, and that becomes 27. And take the square root, and c is equal to the square root of 27, which is equivalent to 5.2. And what that is that's the distance from the center. So I have 1, 2, 3, 4, 5.2, which is really going to be negative 2.2. So I have my equation here. The length of the major axis is 12. The minor axis is 6. You have your vertices there. I'm not going to list all the points. And the foci. Because this is 5.2 away from the center, I counted it, and that's going to be negative 2.2. X and my y is still positive 2. And my other one is 5.2 away in this direction. 1, 2, 3, 4, 5.2. So that's going to be 8.2. And those are the foci. And we can graph it. So go ahead and give yourself a shot and try these two. If you have to, draw this first one out. It makes it a lot easier. And try to complete the squares for these. Remember, you're going to have to divide by what's on the other side of the equation to make that a 1. And that's how you get your denominators. If you're having trouble with it, it's okay. We'll go over more in class. So for the first one, you should have gotten the center at 3, 8. I labeled these by 2, so it fit on there a little bit better. And the A as a distance of 6, and the B as a distance of 4. So when you do it, x minus 3 squared plus x minus 3 squared over 36 over the A plus y minus 8 squared over 16 is equal to 1. And here's the answers to the second one. You had the center at 1, negative 3 after I added 1 for this one, and I had to add 9 inside the parentheses, but there was this 4 outside, so I really added 36, which meant I had to add 36 out here. That makes this 16. Divide by 16, I get 16 for the x and 4 in the denominator under the y, which means it's a horizontal because the x has the larger denominator. The distance of the A is 4, the square root is 16. The distance of the B is 2, the square root of 4, which means the lengths are twice of that for the major axis and the minor axis. So I had my vertices based off of that, and I found the C by doing the A squared minus B squared, which became 12. Square root that, it's about 1.9, and then went from the center 1.9 to get those foci. What gets Lady Gaga mad every time? Poker face. Poker face.